Okay, now we can continue. And I figured out how to add my face so y'all can actually see me. Pause the good music there for a second. So we're going to continue on now that we have the three basic Newtonian laws under our belts. So now we want to talk about forces, and forces are at play at universe, and can we name them? So haven't talked too much exactly what forces are. We've talked about a few examples of them. Frictional force I highlighted, gravitational force I highlighted. It's something that pulls on something else, and the force, for it to be a force, it must have mass and it must have acceleration. So if you can name some forces at play in the universe, that would be awesome. Go ahead and pause this video real quick and list them off. That'll be great. There's at least 9 of them that I can think of here. So go ahead and pause. Okay, and so the ones that are at play in the universe are, there's the contact forces, and then there's the action at a distant forces. And you'll hear that there's 4 different forces at play, the 4 major forces, but this is kind of breakup of those forces into more of them. So frictional force I mentioned. Tension force is the force between ropes and objects, or not just ropes, like wires and stuff like that. The normal force is what holds us from falling through the floor. Gravity is pushing us down, and the normal force is pushing us back up off the ground and preventing us from going to the center of the earth. Air resistance force, that one's pretty self-explanatory. Throw a ball in the air or shoot a bullet and it's going to slow down before it hits the ground. The applied force is a force that you apply to something. If you push your TV or a couch across the floor, you're applying a force to move the couch. Spring force is in springs. It's a bit of a complicated force to understand, but you have a spring at rest, you start to compress it, and it's gaining more potential energy. You let go, and then it pushes your hand away, right? Or even when you're compressing it, it's trying to push your hand away. Action at a distance forces, gravitational force pushing you down, right? Electrical force, you have 2 positive charges, and if anybody knows the phrase, like charges repel each other and opposite forces or charges attract each other. Maybe you got that, maybe you didn't. So there's that one. So if you have 2 positive objects, which are called protons, and you put them close together, they're going to exert a very strong electrical force on each other, trying to push each other away. Magnetic force has to do with atoms or charges also being in one direction. So, you use the magnet to pick up metal and stuff, so there's an attraction there. Those are the different forces, and I want you all to learn more about them, so you're going to watch a crash course video for 3 different forces, but we'll get to that later. That'll be your homework, one of your homeworks here in just a minute. So there's your homework assignments for this coming week, which will be due next Tuesday, or this coming up Tuesday, I'm sorry. So you'll need to review your lab reports from last week. As I left comments, I want to make sure that y'all guys improve your writing. Y'all did a great job, but there's always room for improvement, right? And then the lab report for the experiment that you will have done today, we'll explain what the experiment is. There's just going to be 1 lab report for next week. And then afterwards, you're going to do your own little experiment. I think it's going to be quite fun. I wish I had Legos here to do it. But you're going to design a Lego building that can withstand an earthquake. You're not going to do a lab report on it. There's going to be instructions. I've already sent the email to y'all guys. So just look at the email. It has all these homeworks, assignments, and in that email is a link to the instructions for this experiment. Just note that there's different tabs in there. It'll be like background, abstract, materials, and the procedure. So just look at the materials that you'll need and procedure. And there is some substitute things that I threw in there because I'm pretty sure you're not going to have all the supplies that you need, but there's some substitute ones there. And then, like I was saying, watch a Crash Course video on the forces. Crash Course does a really good job, just like Khan Academy, of explaining different scientific ideas. The beauty of Crash Course, unlike Khan Academy, is that it doesn't get too complicated. It starts basically from scratch, and there's not any math involved in it. So you can take a relatively complex idea and just start to appreciate it with a Crash Course. And they do science, they do history, all kinds of different stuff. Those guys are geniuses, and they make really good videos with information that is put together very well in a way that you can understand it. So what you're going to do today is you're going to do an experiment on calculating the acceleration and speed of an object, which will be a car in this case. So we need to look at what forces are at play this car. The car will be up on a ramp with some books or whatever you need to use to hold it up. And it's going to travel down the ramp, right? That's what cars do. Granted that they don't have the brakes on, and since it's a core toy, I don't think they will have left the brakes on. So if this was a flat surface, the car would not go, right? If it was flat like this, there would be no acceleration there. So what is giving the car the incentive to move? What's providing the force? Anyone? Anyone? I'm just kidding. A little Ferris Bueller for you. Gravitational force pulls the car downwards. So the gravitational force is always, how do you say it? Going towards the center of the earth. So it's always straight downwards. So it's pulling it down, and since it's pulling it down the ramp, even though there is motion in the x and y axis, right? The gravitational force is pulling it there. What slows it down? What makes the car have a force in that way? Anyone? It would be the frictional force. There is friction between the tires and the board. What is friction? It's an attraction between two objects as they move through each other. So a surface is not completely flat, right? Even what looks to our eye completely flat marble. There's still some atoms that have, let's just say for explanational purposes, space in between them. And so when you have an object moving across them, it's kind of gets stuck in the grooves there. That's one explanation of it. As a chemist, I would like to say that there is molecular attractions in between those also, because you have the electrons on the shell, right? And then if the other electrons can move out of the way, then there's there is an attraction between the proton of one of the nucleuses and the electrons of the other atom. So they attract it for just a little bit in time until they move away, and then there's no more attraction on that one. It'd be a different atom. So we have that going on. There's friction and there's gravity. So you're just going to let the car roll down. You're not going to push it. There will be no applied force. That'll be the only two forces applied on here. And to make sure you showed up to class and are paying attention, you will not find this information anywhere else, so please pay attention. If you write the two forces I just mentioned in your lab report and the analysis and in the conclusion that those were the forces at play, you'll get extra credit for it. So mention those forces and what they do, right? It's the frictional force, gravitational force, and what they're doing on this object and why that's important to this experiment. So those are the forces at play. So what we're going to do is measure the acceleration and the speed. So those can be calculated with different equations than the ones we've seen here, but speed you can calculate by distance divided by time, right? That'll give you speed. And then acceleration is distance divided by time divided by time. So divided by time twice. So you're going to, at this point, you're going to get the lab manual and you're going to perform the experiment. Just make sure that you do you're going to have to calculate the times, right, and the distance. For the times, make sure you do 5 times and average those times for your lab reports. The math, I'm going to put an example one on my Google Sheets of how the math can be done to where it gives you the averages and then the equations that you're going to use. It's a little bit more complicated, the equations that we're using on this one. Not too bad, but I'll just make sure y'all guys have a reference point on that. So go ahead and do that. And have a great week. Get your homework done. Don't do drugs. And yeah, thanks for being my students.